We are transitioning. The transition.
We have transitioned.
The transitions.
Transition has occurred. What's up, folks?
You guys just watched me fade in or slide in. I just
Did you
slid
just
in.
like do the you did your own transition?
Yeah, I just kind of did my own transition in. How
Do
we
you
feel
want a
about
transition in? I can give you a transition. Hold up.
How we feel about this NFL draft. I didn't even know there was an NFL draft. I'm really behind.
That's
I
funny.
I was waiting for someone to ask this question. I was waiting for somebody to ask this question, and I
But
knew
the
it was
Super
going to
League or the
happen.
link to list question?
Both. Both. But mostly the Super League question. I was waiting for this.
Do you have an answer?
that, but I will answer a little later. I want to
We
get.
will answer Super League questions towards the end of the review session.
Yes, I have no
And
problem
yes.
answering it.
Yes, we went over linked lists last week.
Yes, we actually did go over linked list last week. Can I ask questions regarding the final exam? I believe, Yusuf, you are from Nazrin's class. So you can, but I don't really have any answers for you. I mean, I'm going to be completely honest. The final exam is in, 3 weeks from now? So we can't exactly give you any concrete things. And I don't want to mislead you, so. Can we do BFS? Logan, what did I say? We said it was going to be a more chill review session.
I said,
And we got people. We got people asking about BFS.
Immediate. Okay. So we're at a slight bit of a crossroads this week. Nazrin's section has gone to do. What'd you guys do? Graphs?
Yeah, we did graphs.
Oh wait, I guess we did graphs too, because Jesse introduced BFS. Hold on.
Did he?
Did we do graphs? Hold on. I might be just being dumb. No, we didn't do graphs. Okay. Yeah,
He
okay, so yeah,
introduced-
Jesse's section did binary search trees, Nazrin's section did graphs. So we're in a weird place in which neither section knows what the other section knows. So I was gonna go over both of them next week. Because to be honest, it's easy enough to go over both of them next week. When both sections know both the content. But I guess we can go over both of them this week, and then again next week.
So, Priest Pope, you want us to go over BFS, or you want us to go over BST?
I think it's BFS.
I'm pretty sure he wants BFS. I just want to make sure. BFS. Okay. All right. We can definitely go over BFS. Okay. Sure.
All right, let's go over BFS, and then we can double back to binary search trees if we need to. I think Jesse's slides for this, because I want the UCLA thing.
I have no. I mean, we have the UCLA thing as well.
No, I know, but I mean, I think I want these slides. I don't think I have slides for this.
Yeah. Definitely go to Jesse then, for sure.
All right. So, welcome to slides. Okay. So this is a graph. We're gonna run binary search by BFS. We're gonna run breadth first search on this. So, we have UCLA. Where are we gonna go from UCLA? That's where we're gonna start.
I don't know, man. Let's go to Lincoln or Carnegie. Come on, let's just choose.
Oh, I didn't mean to go to. I was just talking about BFS in general. But okay, that's fine.
Okay.
So from UCLA, the first thing we're gonna go to is we're gonna go to Stanford. Then we're gonna go to everything that's connected to UCLA. So we're gonna go to Stanford. Then we're gonna go to SRI. So 1, 2, 3, 4. Right. We're gonna go to UCSB. Then we're gonna go to Rand. Right. From there, we're gonna say, okay, let's go back and explore each of these nodes. So we're going to go to Stanford and we're going to go, okay, let's explore. It goes to SRI. Well, we already know what SRI is, so we don't need to explore this any further. That's the only thing that Stanford's connected to. Let's go to the next one. Let's go to SRI. Okay, let's explore SRI. So SRI goes to Utah. Okay, cool. Now we're going to move on to UCSB. UCSB goes, okay, I go to SRI, and I go to Rand. And then we go, cool. Then we go to Rand. Then we go to Rand. And Rand goes, I go to UCSB. I go to SDC. I go to BBN. Then we go, cool, again. So then we go back to the very first thing that the last thing that we found but didn't explore, right? So that's going to be Utah. So the first thing we explored but we haven't gone further into. So we're going to go to Utah. Utah's going to go, okay, well, I'm adjacent to SDC. I'm adjacent to MIT. Cool. So now we're going to go to next. Well, Rand explored SDC. So we're going to explore it from SDC. Well, SDC goes, well, I'm connected to Utah. And that's it. We go, cool. And then we go back to Rand, and Rand goes, well, I'm connected to BBN. So BBN goes, okay, cool. Hi, I'm BBN. Let's explore BBN. So I'm connected to MIT. I'm connected to Harvard. And he goes, cool. Then we go back to MIT, and MIT goes, okay, well, I am connected to Lincoln and BBN. And then we continue to go until everything is mapped to everything else. Okay, what is happening when you're exploring a certain node? So let's clean this. That's the highlighter, not the cleaning.
You gotta
tool.
find the eraser.
That's wrong tool.
No, we want to highlight the arrows.
When we explore a node, so let's take UCLA, right? When we explore UCLA, we're saying what is adjacent to UCLA. Okay, and that stuff gets a distance of 1. So Stanford, so this is a distance of 1. 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 Now we're going to go look at all the secondary distance from UCLA, right? So that's any node that's attached to any of these. So this will have a distance of 2. So for example, SRI, Utah is attached to SRI, so that'll have a distance of 2. SDC is attached to RAND, which is attached to UCLA. That will have a distance of 2. BBN is attached to RAND, which is attached to UCLA. That will have a distance of 2. And what we're doing is we're going and looking at anything that's adjacent to this node and saying that is distance away 2, unless it already has a smaller distance. For example, UCSB is technically 2 away from UCLA, but it takes precedent on the fact that it's actually directly connected to UCLA. So then we go again. We go to the 2s and we go say, what's adjacent here? Now it's 3 away, right? So Utah is 2 away. So we go, what is next to Utah? SDC? Well, SDC already has a 2, so its shortest distance is going to be 2. MIT? That doesn't have anything on it yet, so that's going to be a shortest distance of 3. BBN is going to go here and goes and go MIT. Well, that's the same thing. It doesn't really matter. Harvard will have a distance of 3. And we continue to go through our different sets. So the distances away of our adjacency lists. So when we explore a node, for example, starting with UCLA, and Spotify is really dumb, so it just paused, which is cool. When we, I know exactly why I paused too. It's because of Discord and Spotify. When we explore, we're saying what is adjacent to this node. That is now 1 plus the existing distance, and the distance starts here at 0. So basically, we're creating a graph, we're creating a list that says what is the distance between everything. So that way we know what the quickest route to get there is. So let me continue to fill this in. This is going to be a 4. And this is also going to be a 4. And this will be a 5 either way you look at it. Boom, BFS. All right, we've gone over everything. We can leave now.
Explores everything.
It explores everything. But it explores it in an order of being breadth. So, for example, the best way to explain this is You guys in your computer science careers, you have to take breadth classes and depth classes, right? Breadth classes is a wide variety of classes, right? Depth classes is very specific in a deeper line, right? So breadth covers like all of this area, right? But depth is only going to cover this area. So breadth first search is going to explore at a wide basis on every single thing. I don't know why I talked about depth because we didn't go over DFS, but
we
won't.
You guys do not need to know DFS. And I would suggest not searching it up because you will
get scary.
Yourself.
It gets scary.
It's very scary.
But if you ever forget what breadth per search does, you remember that breadth means like a wide variety. So we're exploring anything, and then we explore that stuff.
Anybody got any questions on that? Or would they like to see how the code itself works?
Hear me out. Can y'all reverse a binary tree? A tree?
Oof.
Yes, you should never need to. Unless you're doing the project Leo's doing.
Please don't ever do it. Don't ever willingly do it. I'll say that. Don't ever willingly do it.
Wait, hold up. I can pull the chat up here. This is way easier. Hold on.
I can see.
I know, but I want to see it without looking over to the right monitor. So say you have two different paths between two nodes, one being longer than the other. How do you keep track of both of the paths in your code, if that makes sense? You don't keep track of both the paths in the code. You only keep track of the shortest distance. So for all intents and purposes, right? Random UCSB, that doesn't exist. Because there's no reason that if you're starting at UCLA, that you would ever go to UCSB from Rand. Okay. Code. Hello, repetition.
Repetition. Wait, it's not even repetition, it's repetiton. Repetiton.
Yes.
Yes. I love it.
By the way, I would like to say this is how I get to Jesse's GitHub every time. It's not by going through the course website, it's actually going to the GitHub website.
Awful. You're awful.
Well, no, the best part is what nobody saw was the learning objective quizzes repo. Which
you're awful.
Bro, it's private to high L, so it doesn't really matter.
You're awful. Why? We could have just went to the website. I don't know why you made it so much more difficult.
Because that sounds like way more fun.
Playing with fire.
Always. All right. This is BFS. It's not a very difficult thing, to be honest. Like, to understand, if that makes sense. It kind of just takes a lot of concepts that you guys just recently learned. So it involves graphs and involves queues. Also, yeah, every single human that ever takes this class steals this code.
Yes.
What do you mean? Why did I mute my sound on Discord?
So muted. Wait, what?
Well, I didn't mute my sound on Discord. What?
Anyways,
I just closed Slack to make sure that there was no messages that went through. I didn't mute anything.
Oh well. Also, yes, you can steal this code, but be prepared for the consequences next semester when you steal the code. When you actually have to do it yourself.
Hey, I think I stole it anyway, but... okay, regardless. Basically, you have this set called exports. That way you don't explore things multiple times. Sets are lists, but they can only have a single value once. I also have to open this window, because it's making my face look really weird lighting-wise, and it's bugging me. So, explored basically makes sure that you don't ever explore a node twice. Okay? So we have a distance map, which is integer. So let's duplicate this tab. Graph. So, that's not what I'm looking for. This is what I'm looking for. We added nodes here, right? With an integer referring to which node is which. So, in our map of integer to integer, this integer here, is a integer of what node this is and what distance away this is. So the distance for our start ID. So in our case here, let's do one of these and one of these.
And one of these and one
of these. Oh, but this didn't actually.
Yeah, I don't know why it does that sometimes.
It does it all the time for me. It's really annoying, actually. Okay, so our distance for the first node is going to be -1 because it doesn't exist, right? That's our first node, and then we say, what do we want to explore? So we're gonna add the starting ID. So in this case, it's UCLA. I'm actually gonna erase. Okay, I finished erasing. Okay, so we're gonna start exploring. So when we explore, we add our starting ID to our explorer queue. Okay, now queues are really cool functions that you guys will use. Basically, they act like a line. So like a list in which you pop the beginning off of and pop the end off of. Yeah, exactly as repetition said, first in, first out. So the first person in the line is the first person to get out of the line. So while this exploring list is not empty, so while there's stuff in it, we're going to take out the node to explore. We're going to go through every single thing in its graph adjacency list. Cream soda again to me. We're gonna look at everything in its adjacency list. So that would be Stanford, SRI, UCSB, Rand. We're gonna print the line that we're exploring that node. And as long as we don't contain that node, we're gonna say the distance is. We're gonna add the distance to the list. Where do we add the distance list? Where does the distance get added? Or am I being really dumb?
No, this distance.
Oh no, it's literally right here. It is right here. Yeah. I'm just being dumb. Yeah.
Mm-hmm.
So we're gonna add the distance of the node to explore to the list, and then we're going to explore. We're going to add this node to the back of the queue, so that way we will at one point come back to it to explore it itself, and then add this node. So let's start with Stanford. We'll add this node to the set, so that way we don't explore this node again, and then we continue along in a loop. I swear, it's not the most complicated thing known to humankind. So you can go run this on your computers. It's fully available in Jesse's 116 examples, and if you're in Nazarene section, it's in wherever you guys get your stuff from.
In the course documents, guys.
It's in the course documents on whatever site that is.
On UP Learns.
Yeah, that thing.
That nasty site.
Yeah. Okay, let's talk about a couple more things to do with graphs. This is a graph on the left, if you didn't know. The left, if you didn't know. Let's talk about one important thing about graphs, which make them a graph versus being a tree. Trees are just connected downward. Downward and upward. There's no lateral connections. So graphs will actually be laterally connected. So if I said right now that none of the stuff here existed, right? And I said that Stanford to SRI didn't exist and SRI to UCSB, if that didn't exist, that would be a tree. That would be a functional tree. It'd be a weird tree, but it'd be a functional tree. So the main cool thing about graphs is that they can be what we call cyclical, which means that you can get from one point back to the same point without repeating anything. So I can go from UCLA, let's go in this nice dark shade of purple. I can do this to this to this. I can go in a circle and never go to a duplicate and still get back to the same thing. I think that's from any node, if I'm correct.
It should be from any node.
I think it's from any node. So if I want to go from Carnegie back to Carnegie, I can go.
Unless the graph is just not connected.
Well, yeah, but we don't talk about that.
But we don't talk about that.
A graph is like a messy linked list, but with IDs and maps. Yeah.
Yep.
In the line of code that adds distance, when it set the distance of each adjacent node equal to 0 when it should be 1?
Nope.
Yes.
Wait. Yes. Wait. No. When it's at the distance of each adjacent node equal to 0 when it should be 1. Node. Yes. Yes. I'm trying to make sure.
Yeah, I'm trying to make sure I'm right as well.
On the first run through of the loop, and when the initial node is 0. Node.
I think 0 means that it's 0 away. It's connected immediately, and 1 means it's 1 away. I think that's what that means. I'd go watch Jesse's lecture on BFS because he wrote this BFS. So I'd assume what it means is -1 means you're here, 0 means you are directly connected, 1 means you are 1 step away. It's like the degrees of Kevin Bacon. I'm really happy I got to fit that in there. The second I started talking about that, I was like, yo, I have to now talk about the degrees of Kevin Bacon. James, go to office hours for that. We don't we don't do specific questions on homework here. We do conceptual questions.
Yep. No specific homework questions or lecture tasks.
How do you summon a dragon? I snap my fingers. Dragon.
I find a princess and stick her in a tower.
You ready?
Oh my god, yes.
I summoned a dragon.
Wait. We have summoned a dragon. You've also shown your location on Google. So
you can't see my location. You just know I'm on Long Island, which, like, fair play.
Fair play.
I'm pretty sure I've shown my house on Google Maps on Twitch stream already, so it's not like I'm wrong here. You do var dragon : dragon equals new dragon. Open close paren.
Yeah.
That's how you summon a new dragon.
That's also a good way to just summon a new dragon. So I'm still trying to make sure when it's at the distance of each adjacent node equal to 0 when it should be 1.
Well, okay, we can test this. Hold on. I just opened Internet Explorer instead of IntelliJ. Yep, it's that kind of day.
Please don't ever open Internet Explorer.
I didn't mean to.
So actually, I do not think it would be. No, I do not think the code sets it equal to 0. But I forgot the reason as to why that is.
There is a reason.
Yeah.
I don't remember what it is, though.
I'm trying to make sure, and I'm trying to think about why. There's a specific reason as to why that doesn't happen.
Hold up, wait. There's the distances here. Hold on. Oh, because when you start with the first node, it adds the first node to itself.
Yeah.
Look, okay. We found it. Okay. I swear. Desktop. Here we go. When we start with Carnegie, when it runs through the code, it says Carnegie 0. Because it adds 1 to the thing.
Yeah.
So you have to start at -1 for it to go through, because you add Carnegie to the queue of things to explore.
Mm-hmm.
And then as we go through, it then does Harvard and Case, which are each 1 away. And then it goes to Lincoln, which is 2 away, etc. Jesse literally goes through the entirety of BFS in this, and slide by slide based on how far stuff is away. And he actually goes through pathfinding using BFS here. I'm not going to totally go through this, but
please don't.
This is a thing that you should look at if you're having trouble with pathfinding for either of the last homeworks, because the homeworks are similar.
Very similar.
They're not that similar. Ours is
They're
Towers
not similar
2.
at all, but
Ours is Towers 2.
that was awful. Apologize to chat for burping that loud.
Absolutely not.
Nah, the chat deserves an apology.
False. What is this project I'm in?
You know, I would love to know what it is.
This is the review session project. It's not the quizzes. That's the important thing.
That priest pope should decide on your fate. I would like to keep my fate in my own hands. Thank you very much.
I think they mean my fate because
Oh,
I
your
burped.
fate? Oh, I definitely believe you should decide Logan's fate at this point. Logan can give you all +2 on the homework.
That's not true.
No, that's just not true.
I don't have that kind of privilege.
Yeah, no, that is.
It's like
so
hiring and firing power. I don't have that.
What's up, Inherent Clown? We went over graphs and BFS.
Correct. And we're gonna go look at BFS running.
Some running
And
BFS.
by look at BFS running, I mean I'm literally just gonna click the play button and let BFS go. It's super simple. If
Let's just
IntelliJ
open my-
wants to like,
Let's
not
just
die.
open my 250 project. We can look at a bunch of graphs there.
Yeah, we went over how to summon a dragon.
Yes.
We went over the fact that Leo has thoughts on Super League, but he
Yes.
hasn't told anyone them yet.
But
because
I
he
will
wants
not.
to wait.
I am saving my thoughts on Super League.
But he has them.
But the thoughts are there.
The thoughts exist.
Thoughts exist. They are existing in my conscience. What a great project name. Just name it BFS and call it a day.
Oh, fuck that, man.
BFS
That sounds like
and
way
stuff.
too much. Way less fun. Oh, you know what? This is a pain in the ass to do. Because I have to bring in a queue and I have to bring in the graph structures.
Well, here's the thing. Just download the entire repo.
That's what I'm doing. I don't even know if this knows what my GitHub account is. Like,
It doesn't, clearly.
oh
'cause it
wait,
says no
wait,
account.
I have this already. Wait, hold on. Apparently, I have this. Hold phone. I think this is legit last semester's, but
That's okay.
BFS
it
doesn't change.
BFS never changes.
I do trust this project. I swear.
I trust it a lot.
I trusted at least 3%.
Why did IntelliJ add that feature? I am not a fan of it.
Yeah, this is definitely last
I am not a fan
semester's.
of it. I'm not.
Oh god, now I have to go find it. Here
It's
we
right there. It's fine. Hello, BFS.
go. Okay. Welcome to what it used to look like when we did it week by week. This is super behind actually. Let's set up a JDK and SDK. What are we on? Version 15 now? I think we're on 15, and then
Yes, but the POM won't work. I would not change it. The POM won't work.
that's probably a good choice. Project structure. Okay, don't do what I'm doing. How do I change the projects SDK? Hold on. Well, I also don't know why that appears so small. Don't worry about this. This is not a thing you should do.
Don't do this.
Don't do this. Can we get a banner that says, please do not try this at home? Why is it so flippin' bright out? Jesus Christ. Yo, my camera's at 1.8, right? 500.
What the hell?
My shutter speed's at
So bright.
500 right now.
That's so bright outside. Then what the heck?
Why is it so bright? Alright, so if I go to graph example, right, and I run this is the same graph example we were just looking at. So hopefully this works, because I might have just screwed up my job up, but it's okay.
Yeah, I think you might have. I think you might need
It's
to go back
fine.
to.
It's fine. Don't worry about it. So I'd like to say I can't actually see the monitor in front of me because it's glaring. So I'm looking at the monitor to the right of me, which is OBS. Yeah, this doesn't really. This is what you don't like. Can I just like comment out this whole class? I hope nothing was relying on that. How are my colors different? Because I got a theme.
It's called themes.
Oh, I think a cloud came. A cloud came. My eyes are saved.
Oh my gosh.
Import JavaFX. You know what? This is super simple. Where's the... Okay, there's that. Just delete.
Just delete everything but
Just literally delete everything unless it's linked lists or graphs. I don't care about anything
and a
else.
queue. And a queue. Don't forget the queue.
I think that's all in here.
Yeah, it is. It should be.
Linked list, yeah.
It should be.
This is what you get when you do things.
All right, let's try it now.
Take 17.3. Where
Size,
is this
scale,
linked list node?
It's in.
What?
It's just the palm. It's the palm. It's the palm.
I don't think it
telling you.
is. No, it's having inheritance issues. You know what? There's an easier solution to this. There's a way easier solution to this. Hold on. Where's I? Is it not here?
No, you gotta.
Where's idea projects?
It's not in documents. It's not in documents.
Is it not? What the fuck
No,
is it?
it's you gotta go into your local disk and then it's in.
Oh shit! Every time. Also, welcome to my computer. It's a thing. File, close project. I've skipped it like 3 times. Okay, this is the easy way to do it. There we go.
Now we can just call it a day.
There we go. I trust it. I swear.
All right. Let's restart this. Yes, you see Overwolf. We're not going to talk about Overwolf.
Okay, so if I come here to graphs and graph example, I swear to
And
God,
run
this
it.
isn't gonna work. 100% this isn't gonna
It's all
work.
good. It's all good. Okay. Run it.
Wow, it's really taking a sweet time to run this.
You love when it takes 10 years to compile. There we go.
So to explore things in this order, which is roughly what it should have done. So this is doing this.
I just realized why it works. I just realized why it works.
Is
in
it
BFS.
because it's correct?
It's no, but I realized the actual reason as to why it works.
Okay. So
That's okay.
from UCLA, it goes to RAND, then UCSB, then to SRI, then Stanford, then it does BBN. That should be a 5. 5, 6. Then from SDC, it explores Utah, which is actually from SRI connection. Then it goes to Harvard, which is 8, 9, and then I think it'll be 10, 11, 12. Yeah. So because it starts on, when we did it in our heads, right? We said we start on Stanford. This one started on Rand. Doesn't really matter where you start because it still gets the same distances for all of them.
Yep.
Doesn't start at UCLA. Correct, it does.
Yep.
But UCLA says, what are my adjacencies? Our first adjacency is Rand, so that's where it starts. It starts from UCLA there. I heard it like UCLA. So it won't say that it explores UCLA.
Yeah, at UCLA it just explored. That's
just,
all it is.
It just is at. It doesn't like purposely go through exploring, if that makes sense. What just disconnected from my PC?
I thought that was me.
No, I
genuinely
think
thought
that was me.
No, I'm pretty sure it was you. So you wouldn't be able to find distances between nodes without BFS. Yes.
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 I mean, you could have just be really difficult.
yeah. BFS simplifies it.
BFS is easy, even though you may or may not think it's actually easy.